Hi, dear friend. You've found a quiet place to rest and dream. Tonight we'll journey into the ancient dance of stars as they find each other across the darkness, collide, and become something entirely new. Let yourself settle now. However you've arrived here, whatever weight you've carried through your day, you can set it down. The universe has been unfolding for billions of years, and in this moment, all it asks of you is to rest, to breathe, to let your body sink a little deeper into comfort. There's nowhere else you need to be, nothing you need to solve or fix or remember. The story will continue whether you're awake or drifting, whether your eyes are open or closed. You are safe here, held in this quiet space between waking and sleep, where science becomes poetry and acts become lullabies. So take a breath with me now, slowly in and slowly out. Feel your shoulders drop just a fraction. Feel the tension in your jaw release. You don't need to try to relax. Simply notice where you are. Notice the softness beneath you. Notice how your breath moves without effort, how your heart beats without instruction. Tonight's journey takes us to places where gravity becomes so intense that space itself warps and bends. Where two ancient suns, having burned for millions or billions of years, spiral toward each other in an embrace that will transform them both. These collisions happen in silence, in the vast emptiness between galaxies, witnessed only by the light they send across impossible distances. And as we explore these cosmic encounters together, you might find your own thoughts slowing, your own busy mind settling like dust after a storm. That's perfectly natural. That's exactly what this time is for. Stars are born in clouds, vast nurseries of gas and dust, drifting through space, slowly collapsing under their own weight. Within these clouds, pockets of matter grow denser, warmer, pulling more material toward themselves. And when the pressure and heat become intense enough, something miraculous happens. Hydrogen atoms begin to fuse, releasing light and energy. A star ignites. Most stars, like our sun, live relatively solitary lives. They burn steadily, converting hydrogen to helium in their cores, shining across billions of miles. But many stars, perhaps most, are born with companions. Binary systems, where two stars orbit a common center of gravity, dancing together through space. Imagine 2 points of light, each brilliant, each powerful, separated by distances that dwarf our entire solar system, yet bound together by invisible threads of gravity. They circle each other slowly, gracefully, like ice skaters holding hands, spinning across a frozen lake that stretches forever. Your breathing is becoming slower now, deeper. You don't need to make it happen. Simply notice how each exhale carries away a little more of the day's residue, how each inhale brings a little more quiet into your body. These stellar companions can orbit each other for millions of years unchanged. But gravity is patient. Gravity is persistent. Over time, over vast stretches of time that make human history seem like a single breath, these stars can draw closer together. Perhaps they lose energy by radiating gravitational ripples in the fabric of space itself, carrying momentum away. Perhaps they interact with surrounding gas, creating friction that slows their orbit. Gradually, incrementally, the distance between them shrinks, and as they grow closer, their dance accelerates. What took 1,000 years for one orbit now takes 100, then 10, then 1. The stars begin to feel each other's gravity, not as a distant tug, but as a profound pull, distorting their shapes, raising tides on their surfaces. If you could watch from a safe distance, impossibly far away, you would see two spheres of burning gas begin to stretch toward each other, like water droplets on a window pane drawn together, elongating before they touch. Let your mind rest with this image. Two ancient lights moving fast and faster, their surfaces beginning to blur, their boundaries beginning to soften. There's something deeply peaceful about witnessing events on this. Human urgency dissolves. Human worry becomes small and distant. When stars collide, the event unfolds differently depending on what kinds of stars they are. If both are still burning, still in the prime of their lives, the collision is a merger. Their outer layers mix and combine. Their cores spiral inward, releasing tremendous energy. The temperature spikes. Nuclear reactions accelerate. Elements that took millions of years to forge in stellar cores suddenly find themselves in environments hot and dense enough to fuse into heavier elements. Carbon combines with oxygen. Neon burns to magnesium. Silicon fuses into iron. For a brief moment, cosmically speaking, the merged star burns brighter than entire galaxies. It outshines billions of ordinary suns. And then, if it's massive enough, it can no longer support its own weight. The core collapses. In less than a second, matter compressed to unimaginable densities rebounds, sending a shock wave outward. The star explodes as a supernova, scattering its newly forged elements across. This is how the universe creates complexity, how it builds the periodic table, one collision at a time. The iron in your blood was forged in the heart of an exploding star. The calcium in your bones was created when stellar cores merged and died. You are quite literally made of stardust. As you rest here, breathing slowly, your body relaxing more with each moment, you're part of this ancient story. The atoms that compose you have journeyed for billions of years through the hearts of stars, through the darkness between galaxies, through clouds and planets, and now through you. You don't need to stay awake for any of this. The story continues in the darkness, in the space between thoughts, in the gentle drift toward sleep. If your mind wanders, that's fine. If your thoughts blur and fragment, that's perfect. You're exactly where you need to be. Some stellar collisions involve stars that have already died, in a sense. White dwarfs, the remnants of stars like our sun, Earth-sized spheres of carbon and oxygen, no longer burning, but still intensely hot. When two white dwarfs spiral together, something remarkable can happen. As they approach, one may begin pulling matter from the other. Gas streams across the gap between them, forming a glowing disk of stolen material. This matter falls onto the surface of the thief star, layer after layer, building up mass. White dwarfs have a limit to how much mass they can hold, about 1.4 times the mass of our sun. It's called the Chandrasekhar limit, named after the physicist who calculated it. Push beyond this limit, and the star can no longer support itself. When a white dwarf crosses this threshold, it doesn't collapse gradually, it detonates. The entire star, roughly the size of Earth, undergoes runaway nuclear fusion all at once. In seconds, it converts a substantial portion of its into energy, according to Einstein's famous equation. The explosion is so uniform, so consistent, that astronomers use these events as cosmic measuring sticks. They're called type Ia supernovae, and they shine with such predictable brightness that by measuring how dim they appear, we can calculate how far away they are. This is how we discovered that the universe's expansion is accelerating. By watching white dwarfs collide in distant galaxies, we learned that space itself is stretching faster and faster, driven by some mysterious dark energy we don't yet understand. Your eyelids might be growing heavy now. That's your body's wisdom recognizing safety, recognizing rest. You don't need to fight it. You don't need to force yourself to hear every word. The universe will keep unfolding whether you're conscious or dreaming. Neutron stars are even stranger. When a massive star explodes, its core can collapse into a sphere just 12 miles across, but containing more mass than our sun. Matter compressed so tightly that protons and electrons merge into neutrons. A teaspoon of neutron star material would weigh as much as a mountain. These objects spin rapidly, sometimes hundreds of times per second, leftover angular momentum from the star that created them. They possess magnetic fields trillions of times stronger than Earth's, so intense they warp the behavior of atoms in their vicinity. When two neutron stars orbit each other, they're among the most extreme systems in the universe. Each is a testament to gravity's power, to nature's ability to compress matter beyond what seems possible. And as they spiral closer, they emit gravitational waves, actual ripples in space-time, carrying energy away from their orbit. Einstein predicted these waves a century ago, but we only detected them directly in 2015. On September 14th of that year, instruments on Earth measured space-time itself, stretching and compressing by less than the width of a proton, as two black holes collided over 1 billion light-years away. 2 years later, on August 17, 2017, we detected something even more remarkable. Two neutron stars orbiting each other in a galaxy 130 million light-years from Earth finally completed their long spiral inward. The gravitational wave detectors felt it first. A chirp in their data, a signal that rose in frequency and amplitude over nearly a minute, as the neutron stars whirled faster and faster, closer and closer, until they merged. Seconds later, gamma-ray telescopes detected a burst of high-energy radiation from the same region of sky, then X-rays, then ultraviolet and visible light, then infrared, then radio waves, every form of electromagnetic radiation, all from this single event. For the first time, humanity witnessed a cosmic collision with both gravitational waves and light. We saw space-time ripple and watched the explosion simultaneously. It was like hearing thunder and seeing lightning at the exact same moment, confirming they came from the same storm. Let yourself drift with this thought. Across 130 million light-years, across a gap so vast that light takes 130 million years to cross it, We felt the space-time ripples of two dead stars finding each other. The universe is connected in ways we're only beginning to understand. Your breathing has found its own rhythm now, slow and steady. Your body knows how to rest. Your mind is learning to let go, thought by thought, releasing its grip on the day. When neutron stars collide, the event is called a kilonova. The merger creates conditions even more extreme than a supernova. Temperatures spike to billions of degrees. Densities approach those in atomic nuclei. And in this crucible, something beautiful happens. Heavy elements are forged, elements heavier than iron, which normal stars can't create efficiently. Gold and platinum, uranium and thorium, the rare earths that make modern technology possible. Scientists estimate that a single neutron star collision produces several Earth masses worth of gold. All the gold in Earth's crust, all the gold ever mined, worn, treasured, fought over, probably came from neutron star collisions in the early days of our galaxy. The wedding ring on someone's finger, the contacts in a smartphone, the gold leaf on ancient temples. All of it was created in the violent embrace of dying stars scattered into space, incorporated into the cloud that eventually formed our sun and planets. You're resting now in a universe that builds beauty through catastrophe. That creates treasure from destruction. That turns endings into beginnings. After the collision, after the initial explosion fades, what remains depends on the total mass. If the combined mass is too great, the merged object can't support itself. It collapses immediately into a black hole, a region where gravity is so strong that not even light can escape. But sometimes, for a brief moment, the merger creates something called a hypermassive neutron star, an object beyond the normal mass limit for neutron stars, held up temporarily by rapid rotation and intense magnetic fields. This hypermassive star might survive for seconds or minutes before it, too, succumbs to gravity and collapses. During its brief existence, it's among the most extreme environments in the universe. Magnetic fields powerful enough to disrupt atomic structure, rotation so fast the surface moves at a significant fraction of light speed, and then silence. The collapse into a black hole happens quickly. The event horizon forms, an invisible boundary marking the point of no return. Matter, light, information, anything that crosses it can never return. Black holes aren't really holes, they're objects with mass, just incredibly A black hole with 3 times the sun's mass would have an event horizon only about 11 miles across. All that matter, enough to outweigh 1 million Earths, compressed into a sphere smaller than a city. You don't need to understand all of this. You don't need to remember any of it. Let the words wash over you like waves on a distant shore. Let the images drift through your mind without grasping them. When 2 black holes orbit each other, they create perhaps the purest demonstration of Einstein's vision. No matter, no light, just curved space-time dancing with itself. 2 wells in the fabric of reality, spiraling together. As they approach, they orbit faster and faster. If you could somehow watch, you'd see nothing directly. Black holes emit no light, but you might see the effect on any surrounding gas or dust, swirling patterns of matter accelerating to incredible speeds, heating up, glowing. The gravitational waves they emit grow stronger, and space itself ripples outward in all directions, carrying the story of this merger to any who can listen. And then at the moment of merger, the two event horizons touch. They form a bridge, then quickly smooth out into a single, larger horizon. The ring-down, it's called. The new black hole settles into its simplest possible shape, a perfect sphere if it's not rotating, an oblate spheroid if it is. The gravitational waves from this final settling carry information about the new black hole's mass and spin. By listening carefully to this cosmic ring, like tapping a bell and hearing its tone, astronomers can measure properties of an object they can never see. Your thoughts are becoming quieter now, more spread out. Like stars viewed from greater and greater distance, each thought more isolated, more surrounded by peaceful darkness. The universe is full of these collisions. They happen constantly, across billions of galaxies throughout all of cosmic history. Some are happening right now in this moment as you rest here. Stars are finding each other, orbiting closer, merging, transforming. And each collision sends ripples through space-time that eventually pass through Earth, through you. Right now, gravitational waves from distant cosmic catastrophes are stretching and compressing the space between your atoms by infinitesimal amount. You can't feel it. The effect is far too small. But it's real. You are constantly bathed in gravitational waves from the universe's violent events, connected to distant dramas by the fabric of reality itself. There's something comforting in that. You're not separate from the cosmos. You're woven into it. The universe flows through you as you flow through it. In the early universe, just a few 100 million years after the Big Bang, the first stars formed. They were different from modern stars. The universe contained only hydrogen, helium, and traces of lithium. No heavier elements existed yet. These primordial stars burned hot and bright, fusing hydrogen into helium much faster than stars today. They were massive, many tens or hundreds of times the sun's mass, and they died young, exploding or collapsing just a few million years. Their deaths seeded space with the first heavy elements: carbon, oxygen, nitrogen, iron. And when the next generation of stars formed, they incorporated these elements. Each generation added more complexity, more diversity to the cosmic palette. The stars that collide today are heirs to billions of years of this enrichment. They're built from the ashes of countless previous generations, and when they collide, they continue the work, forging new elements, scattering them into space, preparing materials for future stars, planets, and perhaps for life. You are the universe reflecting on itself, stardust contemplating stars, atoms arranged in such a way that they can wonder about their origins. Let that thought settle gently in your awareness. You don't need to analyze it. Just let it rest there, like a smooth stone in your palm. Some stellar collisions are slower, gentler affairs. In dense star clusters where thousands of stars are packed into just a few light years, close encounters happen frequently. Stars can have near misses, passing so close that their atmospheres brush, exchanging gas and momentum. Over millions of orbits over countless near misses, stars in these clusters can gradually merge. The process is less violent than a head-on collision, more like two clouds slowly interpenetrating, mixing, becoming one. The result is often a blue straggler, a star that appears younger and bluer than it should be given the cluster's age. These stars have been rejuvenated by their merger, given fresh fuel, a second lease on their stellar lives. They're anomalies, puzzle pieces that initially didn't fit our understanding of stellar evolution, but they reveal an important truth. The universe is messier, more dynamic, more interactive than our simple models. Stars aren't isolated. They influence each other. They exchange material, perturb orbits, sometimes collide and merge. The cosmos is a place of relationship, of connection, of constant interaction. Your body is so... Your muscles have released tensions you didn't even know you were holding. Your mind is quiet, drifting, touching thoughts lightly without grasping them. In galaxies' central regions where supermassive black holes lurk, stellar collisions might happen more frequently. Millions or billions of stars orbit the galactic center in a relatively compact volume. Near these central black holes, the stellar density increases further. Here, stars are jostled by their neighbors, their orbits constantly perturbed. Some are flung outward at high speeds, ejected from the galaxy entirely. Others are nudged inward, falling toward the central black hole. Occasionally, two stars will collide directly, their relative velocity so high that they interpenetrate and merge almost explosively. The collision happens in seconds, creating a brilliant flash of light and a shower of debris. Some of this debris might be captured by the central black hole, spiraling inward, adding to the disk of matter that glows brightly. The black hole grows, atom by atom, fed by the remnants of stellar catastrophe. Our own Milky Way has a supermassive black hole at its center, Sagittarius A star it's called, 4 million times the Sun's mass compressed into a region smaller than Mercury's orbit. Right now, this very moment, stars are orbiting near it at thousands of miles per second. Some complete an orbit in just over a decade. In human terms, that's fast. In cosmic terms, it's a dizzying whirl around the ultimate drain, and someday, perhaps, two of those stars will meet. They'll collide in the darkness creating a brief flash. If we're watching, we'll see 4,000 years later, after the light has had time to cross from there to here. But you don't need to think about that now. You don't need to think about anything. Just rest. Just breathe. Let the story unfold without. When astronomers model stellar collisions using supercomputers, they have to account for incredible complexity. Gravity, hydrodynamics, nuclear reactions, magnetic fields, radiation pressure, all interacting simultaneously. They divide the stars into millions or billions of virtual particles, each tracking its own position, velocity, temperature, and composition. Then they let time advance, tiny fractions of a second at a time, recalculating all the forces, all the interactions, for every single particle. The simulations can take months to run, even on the fastest. But when they're done, they reveal the hidden choreography of collision. They show how shock waves propagate through stellar material, how cores spiral together, how energy is released and distributed. These simulations match remarkably well what we observe when we catch a stellar collision happening in real time. The light curves, the spectra, the energy released. Theory and observation agree, confirming our understanding. It's one of science's quiet triumphs. We can model events that happen at temperatures of billions of degrees, at densities beyond anything achievable on Earth, across distances larger than solar systems, and get the details. Your thoughts are fragmenting now, becoming dreamlike, images without narrative, sensations without interpretation. This is the edge of sleep, the threshold you're crossing gently, naturally. In binary systems where both stars are still burning, there's often a dominant partner. One star is more massive, burns hotter, evolves faster. It reaches the end of its main sequence life first. When this happens, the star expands, swelling into a red giant. Its outer layers extend outward, sometimes reaching far enough to engulf its companion. The smaller star finds itself inside the atmosphere of the larger one, orbiting within a cloud of hot gas. Friction slows the smaller star's orbit. It spirals inward, deeper into the giant's envelope. The process releases energy, heating the gas around both stars. From the outside, the system might brighten, becoming a luminous red nova. Eventually, the smaller star either merges with the giant's core or ejects the giant's outer layers entirely, leaving behind a tight binary of a white dwarf and a normal star. The system has been transformed, reborn through interaction. These common envelope phases, as they're called, are crucial to understanding many exotic stellar systems. They explain how some binary stars end up orbiting so closely, how some white dwarfs acquire companions that will eventually feed them matter and trigger supernova explosions. The universe's most dramatic events often have complex histories. They're not simple, isolated occurrences, but the culmination of long evolutionary paths, shaped by interactions, near misses, and eventual collisions. You are drifting now, floating on a sea of dark water under a sky full of... Some stars are bright, some dim, some are steady, some flicker. You don't need to name them or understand them. Just notice them as you drift. Throughout cosmic history, the rate of stellar collisions has varied. In the early universe, when the first star clusters formed, they were denser than most clusters today. More stars packed into smaller volumes meant more frequent collisions. These collisions helped explain the presence of very massive stars in the early universe. Stars born with hundreds of times the sun's mass, which theory suggested should be rare or impossible to form through normal cloud collapse. But if smaller stars merged repeatedly in dense clusters, they could build up mass, creating these giants through accretion rather than direct formation. The universe found a way, as it always does, to create possibilities theory hadn't anticipated. As the universe aged, as clusters dispersed, and galaxies settled into their current configurations, collision rates probably decreased, but they never stopped. Even today, in the globular clusters orbiting our galaxy, in the dense cores of distant galaxies, stars continue to find each other and merge. Each collision is unique. Each tells its own story, and yet they all follow the same fundamental law: gravity, thermodynamics, nuclear physics. The universe is both creative and consistent, surprising and predictable. Your breathing is so slow now, so deep. Each breath takes you further into relaxation, further from waking thoughts, closer to dreams. Some philosophers and scientists wonder whether stellar collisions might influence the development of life. Heavy elements are essential for planets, for chemistry, for biology, and many heavy elements require violent events to form. Without supernovae and neutron star collisions, the universe would contain almost no elements heavier than iron. No gold or silver, no uranium. Less of the intermediate elements that form rocky planets and enable complex chemistry. Earth itself is a product of stellar violence. The iron core beneath your feet was forged in supernovae. The rocky mantle contains elements from both supernovae and probably ancient neutron star collisions. Every living thing on Earth incorporates atoms from stellar catastrophe. The oxygen you're breathing right now came from stars that died before our sun was born. The carbon in your cells, the calcium in your bones, the iron in your blood, all gifts from stellar collisions and explosions. You exist because stars died, because they collided and merged. Because the universe is not static but dynamic, not isolated but interactive. In a very real sense, you are the universe's way of remembering those events, of holding the memory of stellar catastrophes in the pattern of atoms that form your body and mind. Let yourself be held by this knowledge. You are not separate from the stars. You are star stuff, contemplating, resting after a long day, preparing for sleep and dreams. The story of stellar collisions is also a story of timing. Most binary stars will never collide. Their orbits are too wide, their lifetimes too short. They'll burn, die, and fade long before gravity brings them together. But some systems are perfectly configured. The stars are close enough, their masses are just right. They have time, billions of years, but enough time to spiral together and merge. These systems are accidents of formation, chance arrangements that happen to lead to dramatic conclusions. The universe is full of such accidents of contingencies that lead to specific outcomes. Your own existence is similarly contingent. The right atoms in the right place at the right time, the right planet orbiting the right star, the right conditions for chemistry to become biology, for biology to become complexity, for complexity to become consciousness. You are an accident in the best sense, an unlikely arrangement that nonetheless exists, that nonetheless matters, that nonetheless has value. And right now, in this moment, this accident is resting. This improbable pattern of atoms is letting go of effort, surrendering to sleep, trusting that the universe will continue without constant vigilance. You can let go. You can drift. The stars will keep colliding whether you're awake or asleep. The universe will keep unfolding. And you can simply rest. In some science fiction stories, advanced civilizations mine neutron star collisions for heavy elements. They wait for two neutron stars to merge, then harvest the scattered gold and platinum and rare earth. It's probably impractical. The energies involved are too great, the environment too hostile. But it's a beautiful image. Civilizations advanced enough to treat stellar collisions as resource opportunities, to navigate the aftermath of kilonovae and gather treasure from the debris. Perhaps millions or billions of years from now, if humanity or its descendants survive and spread among the stars, we'll develop such technologies. We'll learn to predict collisions, to position ourselves safely nearby, to collect the heavy elements scattered into space. Or perhaps we'll find other ways to create what we need. Perhaps we'll learn to manipulate matter at the nuclear level directly, transmuting elements at will, making stellar collisions obsolete as resource sources. But even then, we'll probably still watch them, still study them, still marvel at their power and beauty. Because there's something irreducibly awesome about witnessing creation and destruction on cosmic scales. Your mind is barely holding on to consciousness. Thoughts arrive half-formed and dissolve before complete. Images flicker and fade. You're not quite awake, not quite asleep. You're in between, drifting in the threshold space. There are stellar collisions we haven't witnessed yet. Binary systems currently spiraling together, decades or centuries away from merger. Astronomers monitor them, watching for changes, measuring orbital periods, calculating when the final event will occur. Some of these systems are close enough that when they merge, we'll see the event in real time, not delayed by millions of years of light travel, but happening now, in the present moment, visible to our instruments. Future generations will have telescopes far more sensitive than us. They'll detect gravitational waves from collisions billions of light years away at the edge of the observable universe. They'll map the sky in gravitational radiation, creating a new kind of astronomy. And they'll look back at our era as the moment when gravitational wave astronomy was born, when humanity first felt space-time ripple from distant catastrophes and understood what it meant. Each generation adds to our understanding. Each builds on what came before, and each, in its time, marvels at the universe's complexity, at its beauty, at its strange and wonderful mechanisms. You are part of this lineage, this long chain of curious minds, looking up at the stars, asking questions, seeking understanding. And right now, you're also part of the eternal lineage of beings who need rest, who require sleep, who must surrender consciousness for a time to restore themselves. Both are valid, both are important. You can be curious and tired. You can love learning and also need to stop, to rest, to let go. So let go now. Let the story fade into background. Let the words become sounds without meaning. Let the sounds become silence. When two stars collide, they don't disappear. They transform. Energy changes form. Matter rearranges, but nothing is lost. The universe conserves what matters. When you sleep, you don't disappear either. You transform. Consciousness shifts into different modes. The busy analytical mind quiets. Dreams emerge, strange and symbolic. Your body repairs itself, consolidates memories, prepares for tomorrow. Sleep is not emptiness, it's transformation. It's necessary, it's natural, and it's calling you now, gently but insistently. Your body knows needs. Your mind is ready to release control. Somewhere in the universe right now, two stars are orbiting each other for the last time. In a few hours or days, they'll touch, they'll merge, they'll become. And somewhere on Earth, you're drifting towards sleep. In a few moments or minutes, waking consciousness will fade. dreams you'll become something slightly different, the sleeping version of yourself. Both are beautiful. Both are perfect expressions of transformation, change, the constant flux of existence. Let yourself be part of this. Let yourself change from waking to sleeping, from active to passive, from thinking to dreaming. The universe supports you. Gravity holds you to the earth. The ground holds your weight. The air provides breath. Light from our sun, itself forged in the hearts of previous stars, has warmed the world that sustains you. You are held, you are supported, you are safe, and you can sleep now. The stars will keep their appointments. The universe will continue its grand clockwork. Galaxies will turn. Stars will burn and die and collide and create, and you will rest. You will dream. You will restore yourself. Tomorrow, if you wish, you can think about these things again. You can wonder and question and learn. But tonight, now, in this moment, all you need to do is rest. Close your eyes if they're not already closed. Feel the weight of your body. Feel gravity, the same force that brings stars together, holding you gently to the earth. Feel your breath, slow. Feel your heartbeat, calm. You are a temporary arrangement of stardust, resting before it moves on to whatever comes next. And that's beautiful. That's enough. Sleep now, dear friend. Let the story of colliding stars become the story of your dreams. Let the vastness of space become the vastness of sleep's dark ocean. You don't need to remember any of this. You don't need to hold on to anything. Just let it all go gently, easily, naturally. The universe began with a collision of all of existence compressed into an infinitesimal point exploding outward. And since that moment, the universe has been a story of matter, finding itself, interacting, colliding, creating complexity from simplicity. You are part of that story. And right now, your part is to rest. So rest, drift, let go. The stars are far away, but their light reaches you. Photons that traveled for years or centuries or millennia, arriving at your eyes, carrying information about distant suns. Right now, in your closed eye, you can imagine that light. You can picture the stars not as points, but as spheres of plasma, burning fiercely, singing out their light in all directions. Some of those stars are binary. Some will someday collide, and when they do, the light from that collision will set out on a journey across, traveling for countless years until perhaps long after humans are gone, long after Earth itself is dust, that light reaches some other world, some other consciousness, to be witnessed and wondered at. Everything is connected across time and space. Nothing is truly separate. And in this great web of connection, you are a node. A point where the universe reflects on itself. But even nodes need to rest. Even consciousness needs to cease temporarily so it can resume refreshed. Your breathing is barely perceptible now. Your body has settled into its sleeping posture. Your mind is releasing its grip on narrative, on meaning, on coherent thought. This is good. This is right. This is what you came here for. In the dream space that's opening before you, you might see stars. You might see them dancing, spiraling together, touching. You might see light and color and shapes or just the peaceful darkness of deep sleep, where consciousness fully rests. Either way is fine. Either way is perfect. The universe doesn't judge. It simply is. Stars collide not because they should or shouldn't, but because gravity and momentum and the geometry of their orbits brings them together. You sleep not because you've earned it or don't deserve it, but because your body needs it, because biology requires it, because it's time. So let it be time. Let this be the moment when trying stops, when effort ceases, when you simply allow yourself to fall gently into sleep's embrace. You are safe. You are held. The story continues whether you hear it or not. And if morning finds you here, still listening, that's okay too. There's no wrong way to rest, no failure in staying awake. But if sleep has found you, if you've drifted away into dreams or darkness, then this is for you. Sleep well, dear friend. Sleep deep. Let the universe cradle you in its vastness. Let the atoms of your body, once forged in stellar fires, now rest quietly in their temporary arrangement. You are stardust, and to stardust you will one day return. But tonight now, you are consciousness resting. You are awareness gently fading. And that's beautiful. That's exactly what this moment is for. Sleep now. Dream of stars if you wish, or dream of nothing at all. The universe smiles on your rest. The cosmos holds space for your sleep. Good night, dear friend. Good night. The silence between stars is not empty. It's filled with magnetic fields, with cosmic rays, with the faint whisper of the cosmic microwave background, the afterglow of creation itself still cooling after nearly 14 billion years. When stars collide, they break this silence temporarily. They shout light and energy across the void. They announce themselves to the universe. And then, gradually, the light fades, the energy dissipates, and silence returns, deeper than before. Your mind is approaching its own silence. The constant chatter of thoughts is spacing out, becoming intermittent, like stars appearing one by one as twilight deepens. Your thoughts emerge briefly and vanish into darkness. This is the natural rhythm. This is how consciousness prepares for sleep. It doesn't switch off suddenly, but fades gradually, like the last light leaving the evening sky. There are binary star systems so perfectly balanced that they've orbited each other for billions of years without noticeable change. Their dance is stable, predictable, eternal in human terms. They'll continue this waltz for billions more years, perhaps until the universe itself grows cold and dark. Other binaries are unstable, chaotic. Their orbits precess and wobble. Their distances vary wildly. They're systems on the edge of change, and small perturbations might send them spiraling toward collision or fling them apart forever. The universe contains both kinds of systems, stable and unstable, long-lasting and transient, and somehow both are necessary. Both contribute to the rich tapestry of cosmic evolution. Your life, too, contains moments of stability and moments of change, times when everything feels balanced and times when everything shifts. Neither state is wrong. Neither is better. They're just different phases of existence. And right now, in this phase, you're transitioning from waking to sleep, from activity to rest. It's a small change, a personal transition, but it's part of the same universal pattern that governs stars and galaxies. Everything changes, everything flows, and in the flowing, there is peace. Scientists who study stellar collisions often work with enormous data. Observations from dozens of telescopes across the electromagnetic spectrum, gravitational wave data from detectors thousands of miles apart, supercomputer simulations that generate terabytes of information. They're looking for patterns, for signatures that reveal what happened, what kinds of objects collided, how much energy was released. Each collision is a puzzle to solve, a mystery to unravel. But sometimes, in quiet moments, these scientists must also step back, must close their computers, turn off their instruments, and simply rest. Because even curiosity needs to, even the drive to understand requires balance with the need to stop understanding, to stop analyzing, to just be. You don't need to understand everything. You don't need to remember all these facts about stars and collisions and gravitational waves. The universe doesn't require your comprehension to exist. It exists regardless, and you can rest regardless. In ancient cultures, before light pollution hid the stars, people lived intimately with the night sky. They watched the same stars night after night, year after year. They noticed patterns. They created stories. Some of those stories were about violence, gods fighting, heroes battling monsters, the sky as a canvas for cosmic drama. But other stories were about peace, about eternal vigils, about lights that guided travelers home. The sky is a source of comfort and navigation. Both kinds of stories had truth in them. The stars are sites of violence, places where matter is torn apart and reassembled. But they're also steady lights, burning reliably, marking the passage of seasons, helping lost souls find their way. You can hold both truths. The universe is violent and peaceful, chaotic and ordered, destructive and creative. And right now for you, the violence is distant, abstract, happening in places so far away they might as well be imaginary. Here, in this moment, there is only quiet, only rest. Your breath continues, automatic and unnoticed. Your heart beats steadily. Your body performs 1,000 unconscious functions, keeping you alive, keeping you warm, keeping everything working while your conscious mind drifts away. This is one of the great miracles of biology. That consciousness can cease temporarily while life continues. That you can surrender control completely and still be safe, still be healthy, still wake refreshed in the morning. Trust your body. It knows what it's doing. It's been doing this since you were born. Every night of your life, your body has guided you into sleep and brought you back to. It won't fail you now. When massive stars explode as supernova, the shockwave at thousands of miles per second. It plows through surrounding gas, compressing it, heating it, sometimes triggering the formation of new stars. These second-generation stars are born from violence, their nursery clouds compressed by the death throes of previous generations. They inherit the heavy elements scattered by the explosion, incorporating them into their structure. Our sun is one such star, a third or fourth generation star, born from a cloud enriched by previous supernovae and stellar collisions. The planets that orbit it, including Earth, were built from this pre-enriched material. Everything on Earth, every rock and ocean, every tree and animal, every human being, contains atoms that pass through stellar fires. We are inheritors of cosmic catastrophe. We are built from the ashes of dead stars, and yet we don't feel violent. We don't feel catastrophic. Most of the time we feel ordinary. We go about our days. We eat and sleep and dream. We love and worry and hope. The violence is in our past, our deep past, billions of years past. Now, we are peaceful arrangements of once violent matter. You are peace built from ancient chaos. And you can rest in that peace without worry, without... The gaps between your thoughts are lengthening. Seconds pass where there is no thought at all. Just awareness, dim and drifting. Just the sensation of breathing, of existing, without commentary or interpretation. This is the edge of sleep, the boundary zone. Some part of you is still here, listening, following the words. But it's a small part now, and growing smaller. Most of you has already let go. Most of you is already drifting in the pre-dream space, where logic loosens and images arise unbidden. Let that small remaining part. The story has been told. The journey has reached its end. In some binary systems, the stars are so close they share an atmosphere. Their surfaces actually touch, forming a bridge of hot gas between them. They're called contact binaries, and they represent an intermediate stage between separate stars and full merger. These systems are unstable. Over time, friction and tidal forces will cause them to spiral together, completing the merger. But that might take millions of years. For now, they exist in this strange in-between state, neither fully separate nor fully combined. You're in an in-between state, too. Neither fully awake nor fully asleep, hovering in the liminal space where consciousness fades and dreams begin. It's a strange place, this threshold. Time feels different here. Seconds might feel like minutes, or minutes like seconds. Cause and effect loosen their grip. Thoughts arise without apparent source. Don't try to make sense of it. Don't try to hold onto logic or coherence. Just let yourself be in this strange space, this transition zone. Soon, very soon, the transition will come. You'll cross fully into sleep. But until then, you can float here, suspended between states, belonging fully to neither. When neutron stars collide, the event is over in seconds. But the light from the collision, the kilonova glow, can last for days or weeks. It fades gradually, cooling as it expands, changing color from blue-white to red as the temperature drops. Astronomers watch this fade, measuring the light curve, analyzing the spectrum. Each measurement reveals details about the collision, the masses of the original neutron stars, the amount of heavy elements produced, whether a black hole formed immediately or if a hypermassive neutron star survived briefly. These details matter for understanding cosmic evolution, for knowing how the universe creates complexity, for tracing the origins of the elements that make planets and life possible. But the stars themselves don't care about these details. They don't collide for science. They don't create gold and platinum because the universe needs these elements. They collide because gravity is patient and because orbits decay, because nature follows its laws without intention or purpose. And you don't sleep for any grand purpose either. You sleep because you're tired, because your body needs rest, because it's time. That's enough. That's reason enough. Your breathing is so slow now, so soft. Each exhale releases a little more tension. Each inhale brings a little more peace. You're not trying to relax anymore. You've moved beyond trying. Your body has relaxed on its own, naturally, inevitably. This is what happens when you stop fighting, when you stop resisting, when you simply allow whatever wants to happen. Sleep wants to happen. Your body wants to sleep. And there's nothing stopping it now except the last thin thread of awareness that's listening to these words. And even that thread is fraying. Even that last bit of attention is flickering, fading, about to release. In the dreams that are waiting for you, you might visit stars. You might fly between galaxies, witnessing collisions firsthand, feeling the heat and light wash over you without harm. Or you might dream of ordinary things, of people you know, of places you've been, of strange scenarios that make perfect sense in the dream, but will seem absurd when you wake. Or you might not dream. You might sink into the deepest sleep, where even dreams don't penetrate, where there is only darkness and the slow work of. All of these are good. All of these are what you need. The universe doesn't judge your dreams. It doesn't care whether you dream of stars or grocery store, flying or falling. It simply holds space for your sleep. It continues existing, continues unfolding. Billions of stars are burning right now in our galaxy. Trillions in all the galaxies, and in all that vastness and all that cosmic drama. Your rest matters just as much as stellar collisions matter, because you matter. Your experience matters. Your need for sleep and peace and restoration matters. You're not insignificant because you're small compared to stars. You're not meaningless because your life is brief compared to cosmic timescale. You are a place where the universe becomes conscious of it, where matter arranges itself in patterns complex enough to think and feel and wonder. And right now, this precious, improbable consciousness is doing what it needs to do. It's resting. It's preparing for sleep. Honor this need. Respect this moment. Let yourself have this time without guilt or worry or the feeling that you should be doing something else. This is what you should be doing. This is exactly right. The last stars will burn out trillions of years from now. The universe will grow cold and dark and empty. All the collisions will have happened. All the light will have faded. And in that final darkness, there will be a kind of peace, the peace of completion, of stories ended. But that's inconceivably far in the future. Right now, the universe is young and vibrant. Stars are being born. Collisions are creating new elements. Galaxies are forming and evolving. Space is not truly empty. Between the stars, between the galaxies, there exists a thin soup of hydrogen and helium, dust grains and molecules, magnetic fields threading through the darkness like invisible rivers. This interstellar medium, as astronomers call it, is sparse beyond imagination. In the best vacuum we can create on Earth, there are still trillions of atoms per cubic inch. In interstellar space, there might be just one atom per cubic inch, sometimes even less. And yet, this near-nothingness plays a crucial role in stellar collisions. When binary stars orbit each other, they move through this tenuous medium. Over millions of years, the friction, tiny as it is, can steal momentum from their orbit. The stars draw closer, imperceptibly, but the effect accumulates. Time works on scales that make human patience seem like the briefest flicker. Your own patience has brought you here tonight. Perhaps you've struggled with sleep before. Perhaps your mind races when you lie down, rehearsing the day's events or anticipating tomorrow's challenges. Perhaps worry or anxiety keeps you awake, or simply the habit of wakefulness, the difficulty of transitioning from day to night. But tonight, you're letting yourself be guided into rest. You're allowing this story to carry you gently downstream toward the quiet waters of sleep. And just as the interstellar medium works slowly but inevitably on orbiting stars, this narrative is working slowly but inevitably on your consciousness, easing you toward rest. You don't need to force anything. You don't need to try to sleep. Just listen or don't listen. Follow the words or let them become background sound. Either way, sleep will find you when it's ready, when your body and mind have released enough tension, when the conditions are right. Binary stars sometimes exist in systems with more than 2 members, triple star systems, quadruple systems, even systems with 5 or 6 stars, all orbiting their common center of mass in complex nested patterns. In these systems, the dynamics become intricate. A close binary pair might orbit together, while a third star orbits the pair from a greater distance. These hierarchical systems can remain stable for billions of years if the distances, but sometimes over time the orbits shift. The outer star might perturb the inner binary, changing its eccentricity, causing the 2 close companions to approach each other more closely at certain points in their orbit. Or the system might encounter another star, a passerby that disturbs the delicate balance. In dense stellar regions, such encounters happen frequently enough to reshape systems, to turn stable configurations into unstable ones. When instability sets in, the system might eject one of its members entirely, flinging a star out into space at high velocity. Or it might cause 2 of the stars to merge, simplifying the system by force. The universe has ways of resolving complexity, of finding lower energy states. Your mind, too, seeks lower energy states. All day it's been processing information, making decisions, solving problems, maintaining alertness. That requires energy, both literally in the form of glucose and oxygen, and metaphorically in the form of attention and effort. Sleep is the lower energy state, the place where your mind can stop processing, stop deciding, stop maintaining constant vigilance. It's not laziness or weakness, it's wisdom. It's your mind recognizing that restoration requires release, and you're moving toward that state now. You can feel it perhaps in the heaviness of your eyelids, in the way your thoughts are becoming less linear, more associative. Images might be appearing in your mind's eye, random and disconnected. That's good. That's the sign that sleep is approaching. When 2 white dwarfs orbit very closely, separated by less than the diameter of our sun, they experience a phenomenon called tidal heating. Each star raises tides on the other, bulges in the plasma that point toward and away from the companion. As the stars rotate, these bulges move, and the movement generates friction, which generates heat. This heat can be significant. It can cause the white dwarfs to glow more brightly than they otherwise would, adding energy to systems that are, by their nature, cooling remnants of once burning stars. It's a kind of resurrection, a temporary revival of heat and light through interaction rather than fusion. The process also transfers angular momentum between the star's rotation and their orbital motion. Over time, this can synchronize the system, causing the white dwarfs to rotate with the same period as their orbit, always showing the same face to each other, like the moon does to Earth. These tidally locked systems represent a stable configuration, a state of minimum energy for the given orbital parameters, but they're still spiraling together, still losing energy to gravitational waves, still approaching the moment of final contact. Stability is often temporary. What seems permanent on human timescales reveals itself to be transient when viewed across cosmic time. Everything is in motion. Everything is changing. Even the most stable systems are evolving, just slowly. Your life, too, is in constant flux. Cells in your body die and are replaced. Thoughts arise and dissolve. Emotions come and go like weather. Nothing remains exactly the same from one moment to the next, even though the changes are usually too gradual to notice. And right now, you're in a period of transition, from waking to sleeping, from activity to rest, from one state of consciousness to another. It's a change you've made thousands of times before. Your body knows how to do this. Your mind knows how to let go. Trust the process. Trust the transition. Let it unfold naturally, without interference or control. Some binary stars are so old, they've been orbiting each other since the early days of the galaxy. 12 billion years, perhaps. 13. They were born when the universe was young, when the first generations of stars were still enriching the cosmos with heavy elements. These ancient binaries have witnessed nearly the entire history. They were shining when the Milky Way was still forming, when our galaxy collided with and consumed smaller galaxies, building itself into its current spiral structure. They watched, in their way, as our solar system formed just 4.6 billion years ago. They were already ancient then, already orbiting for billions of years. They've outlived countless other stars. They've seen stars born and die in waves, generations of stellar evolution passing while they endured. And if they're close enough, if their orbit is decaying, they might finally merge in our era. After all that time, after all that history, they'll complete their long dance and become one. Their collision will mark the end of a partnership older than most stars currently shining. There's something poignant in that, something that touches even those of us who understand the events as purely physical phenomena, devoid of intention. The sheer duration of their partnership gives it weight, makes the ending feel significant. Your own life contains partnerships and relationships that have lasted years or decades. Friendships, family bonds, perhaps a romantic partnership. These connections have their own history, their own accumulated weight of shared experience. And someday, all of them will end, one way or another. Not through collision and merger usually, but through distance or death, through change or choice. Everything ends eventually. Everything completes its cycle. But that's not a sad truth, or it doesn't have to be. It's simply the nature of existence. Nothing lasts forever, and that's what makes each moment valuable, each interaction precious, each experience worth having. Tonight, this moment is unique. It will never come again. You'll never be exactly this age. in exactly this, hearing exactly these words for the first time again. This particular moment of potential sleep, this specific transition, happens only once. So let it be what it is. Let it have its own character and quality. Don't rush through it trying to get to sleep. Don't fight it trying to stay awake. Just be in it, experiencing it as it unfolds. In very massive binary systems, where each star weighs dozens of times what our sun does, the stellar wind becomes significant. These stars are so hot, so energetic, that they're constantly ejecting material from their surfaces. Streams of particles flow outward at thousands of miles per second, carrying away mass. When two such massive stars orbit closely, their stellar winds collide in the space between them. The collision creates a shock wave, a region where the material from both stars compresses and heats to extreme temperatures, glowing brightly in X-rays. This wind collision zone changes shape as the stars orbit. When they're on opposite sides of their orbit at maximum separation, the collision happens far from both stars. When they're closest together, the collision happens between them, creating a bow shock like the wave that forms at the prow of a ship moving through water. Astronomers can map these collision zones by observing how the X-ray emission varies as the stars orbit. The changing patterns reveal the geometry of the system, the mass loss rate of each star, the speed of the stellar winds. These massive binaries don't usually collide in the way smaller stars. They're so unstable, so short-lived, that they typically explode as supernovae before their orbits decay enough for direct collision. Each star might live only a few million years, a cosmic eye blink, before its core collapses and it tears itself apart. But in those few million years, they shine more brightly than millions of ordinary stars. They dominate their regions of space. They ionize vast clouds, creating glowing nebulae visible across galactic distances. They're beacons, lighthouses, impossible to miss. And then they're gone, exploded, transformed into neutron stars or black holes, or, if unstable enough, completely disrupted, scattered into space without leaving a compact remnant. Life includes these brilliant, brief phases too, periods of intense activity, of high energy, of visibility and impact. Times when you shine brightly, accomplish much, feel fully alive and engaged. But those periods can't last forever. They're unsustainable by their nature. Eventually, you need to return to quieter modes, to rest and restore, to step back from the brightness and intensity. That's what tonight is for. This is your quiet phase, your low energy mode, your time to not shine, to not accomplish, to not be visible or impactful. And that's not only okay, it's necessary. Even the brightest stars would burn out faster if they didn't regulate their energy output. Even the most active systems need periods of lower activity. You're regulating now. You're stepping down from the day's demands. You're allowing yourself to dim, to quiet, to rest. Your body is heavy now. You can feel its weight against whatever surface supports you. Gravity, that same force that brings stars together, that curves space around massive objects, that holds planets in orbit, is holding you gently to the earth. You don't need to support yourself. The ground does that. The furniture does that. You can let your muscles fully relax, can stop holding yourself in any particular position. If you need to shift to become more comfortable, shift, and then settle again, letting gravity do its work. When binary black holes spiral together in their final moments, they orbit each other hundreds of times per second. At these speeds, at these distances, space-time is rippling violently, the fabric of reality itself shaking, vibrating, ringing like a bell struck by a hammer. The black holes themselves can't be seen, they emit no light. But the space-time around them is distorted so severely that if there were any nearby light sources, we'd see strange effects, images bent and distorted. Light from behind the black holes reaching observers who shouldn't be able to see it, bent around by curved space. And then, in a fraction of a second, they merge. The two event horizons touch and combine. A single larger horizon forms, enclosing both black holes. For a brief moment, the new horizon might be asymmetric, distorted, but it quickly settles into a smooth spheroid. The gravitational waves from this final merger are called the ringdown. The space-time around the new black hole vibrates, oscillating, gradually settling into its final configuration. These vibrations radiate away as gravitational waves, carrying information about the new black hole's mass and spin. By analyzing the ring-down signal, astronomers can test Einstein's theory of general relativity in the strongest gravitational fields possible. So far, the theory passes every test. The universe behaves exactly as Einstein predicted it would, even in these extreme environments. There's something reassuring in that the universe follows consistent rules, that we can predict and understand even the most extreme phenomena, that nature, for all its complexity, is fundamentally lawful. Your body, too, follows consistent rules, biological rules, chemical rules, physical rules. Your need for sleep is one of these rules. It's not negotiable or optional. It's a requirement built into the system. And your body is moving toward fulfilling that requirement now. Adenosine has been building up in your brain all day, a byproduct of neural activity, creating sleep pressure. Circadian rhythms, driven by internal clocks, are signaling that it's nighttime, that consciousness should wind down. Melatonin, the sleep hormone, is circulating in your bloodstream, crossing into your brain, binding to receptors that make you drowsy. Neurotransmitters are shifting, inhibitory signals becoming stronger, excitatory signals weakening. All of this is happening automatically, below the level of consciousness. You don't need to direct any of it. You don't even need to be aware of it. Your body is taking care of everything, as it always has, as it always will. All you need to do is not interfere, not fight the drowsiness, not try to stay alert when alertness is no longer needed. Just let go. Just allow. Just surrender to the biological tide carrying you towards sleep. In globular clusters, ancient spherical collections of stars orbiting the outskirts of galaxies, stellar collisions happen more frequently than elsewhere. These clusters are dense, with thousands of stars packed into a sphere just a few dozen light years across. Here, stars pass close to each other regularly. Near misses happen all the time. And occasionally, direct collisions occur, creating blue stragglers and other exotic objects. The core of a globular cluster is a dynamic environment. Stars interact gravitationally, exchanging energy and momentum. Some gain energy and move outward toward the cluster's edge. Others lose energy and sink inward toward the core. Over billions of years, the core can become extremely dense, with stars separated by distances comparable to those between planets in our solar system. In such environments, collisions and close encounters become inevitable. Some globular clusters have formed massive black holes at their centers through repeated stellar collisions. Stars merge, creating more massive stars, which eventually collapse into black holes. These black holes then merge with other black holes, growing steadily. The result can be an intermediate mass black hole, heavier than the stellar mass black holes formed from individual stars, but lighter than the supermassive black holes that lurk in galactic centers. These intermediate mass black holes are rare and difficult to detect, but they provide clues about how supermassive black holes formed in the early universe. Everything in the universe is built through small things combined to form larger things. Atoms form molecules. Molecules form dust grains. Dust grains form asteroids. Asteroids form planets. Stars merge to form larger stars or black holes. Black holes merge to form larger black holes. And in your own life, small moments aggregate into experiences. Experiences aggregate into memories. Memories shape identity. You are built from your history, from the accumulation of everything you've experienced and done. But you don't need to review that history tonight. You don't need to rehearse your memories or reinforce your identity. Tonight, you can let all of that go. You can exist without past or future, without story or narrative. Just this moment, just this breath, just this sensation of rest, of relaxation, of gentle drift. The darkness behind your closed eyes is like the darkness between stars, vast, filled with potential but currently still. This is your interstellar space, your personal void, where consciousness goes to rest. And in this darkness, you might see fleeting lights, phosphines, random firings of neurons in your visual cortex, creating the illusion of light where none exists. These little sparkles are normal, harmless, sometimes even beautiful, and go. Don't try to hold on to them or shape them into anything meaningful. They're just neural noise, the brain's equivalent of static, and they're often a sign that sleep is very close. Your thoughts, too, are becoming more like static, less coherent, less directed. Ideas appear and dissolve before completion. Memories surface briefly and into darkness. This fragmentation is good. This is what happens when the brain stops trying to maintain a coherent narrative, stops trying to make sense of everything. It's letting go of the daytime mode of processing and entering the nighttime mode. Soon, if not already, dreams will begin to form. Strange combinations of memory and imagination, freed from the constraints of logic. And in dreams, you can fly or breathe underwater. In dreams, the dead can speak and the impossible becomes commonplace. Dreams are the brain's way of processing, of sorting through the day's experiences, of consolidating memories and integrating new information with old. But you don't need to understand their purpose or meaning. You just need to let them happen. And if dreams don't come, If you sink into deep, dreamless sleep, that's perfect, too. That's the most restorative kind of sleep, the kind where consciousness fully ceases, where there's only the biological process of restoration and repair. Either way, dreaming or not dreaming, you're moving toward the rest you need, toward the renewal that sleep provides, toward tomorrow's awakening, refreshed and restored. But tomorrow is far away. It doesn't exist yet. Only this moment exists. Only this breath. Only this gentle, continuous drift into deeper and deeper relaxation. The universe is drifting too, expanding. Galaxies moving away from each other, carried by the stretching of space. In billions of years, the expansion might accelerate to the point where galaxies beyond our local group disappear beyond the cosmic horizon, unreachable forever. But that's the far future. Right now, galaxies are still close enough to collide. The Andromeda Galaxy is moving toward the Milky Way, approaching at about 250,000 miles per hour. In about 4 billion years, they'll meet. When they do, there won't be many direct collisions between individual stars. Space is too vast, stars too small and widely separated, but the gravitational interaction will reshape both galaxies, pulling out streamers of stars, distorting spiral arms, eventually merging the two galaxies into one large elliptical galaxy. Our solar system will likely survive, flung into a different orbit, perhaps farther from the galactic center, perhaps closer. The night sky will change. New constellations will form as nearby stars shift position. The view will be unfamiliar to anyone who knew the old sky. But by then the sun will be nearing the end of its life anyway. It will have swollen into a red giant, possibly engulfing Earth. The story of our planet, of our species, will long since have concluded. Everything ends. Everything transforms. And in the transformations, new possibilities emerge. The collision of Andromeda and the Milky Way will create conditions for new star formation, for new planetary systems, for new chances at complexity, and perhaps life. Endings and beginnings are woven together. Every conclusion contains the seeds of something new. Your day is ending. Sleep is beginning. And in tomorrow's waking after tonight's rest, you'll be slightly new. Not completely transformed, but refreshed. Different in subtle ways. For now, let the ending come. Let the day complete itself. Let consciousness finish its work and step aside. You've done enough. You've been enough. Now it's time to stop being, stop doing, stop thinking. Time to rest in the darkness between thoughts. Time to drift in the silence between breaths. Time to let go completely and trust that you'll be caught, held, carried safely through the night. The stars collide in silence, and you're falling into silence too, the quiet at the center of yourself, the stillness that's always there beneath the noise and activity. This stillness is home. This silence is where you return when everything else falls away. And it's welcoming you now with the infinite patience of space itself, with the gentleness of gravity, with the inevitability of rest after work, of sleep after waking. Welcome home, dear friend. Welcome to the stillness. Welcome to the silence. Welcome to sleep. And you are here in this moment of cosmic youth, taking a break. resting for a few hours before you rejoin the unfolding story. Sleep is not an ending, a necessary intermission in the ongoing narrative of your life. When you wake, the universe will still be here. The stars will still be shining. New collisions will be happening somewhere in the depths of space, and you'll be refreshed, ready to engage with whatever your day brings, ready to be conscious again, to think and feel and experience. But that's for later. For the future you who will wake, right now, for the present you, there is only this soft darkness, this gentle fading, this sweet release into sleep. Let go of the day completely. Let go of tomorrow's concerns. Let go of memory and let go of identity itself. Just be awareness dimming into. The stars collide in silence. Space carries no sound. Even the most violent collision happens in perfect quiet. Your entry into sleep is similarly silent. No fanfare, no announcement, just a quiet transition from one state to another, and it's happening now, right now. In this very moment, you're crossing the threshold, you're entering sleep's territory, you're letting go of the waking world, and it's good, it's right, it's exactly what should be happening. Sleep well, dear friend. Sleep deeply. Sleep peacefully. Let the universe hold you. Let gravity cradle you. Let the atoms of your body rest in their temporary arrangement. You are stardust. You are consciousness. You are awareness taking its necessary rest. And when stars collide again, somewhere in the vast darkness, you won't be awake to know it. You'll be sleeping, dreaming, restoring yourself. And that's perfect. That's exactly right. Good night, dear friend. Let the darkness embrace you now. Let sleep come completely. Let everything go. Good night. Let the stars collide in the darkness behind your eyes. Let them merge and transform. Let them create something new. And when you wake, whenever that is, you'll be something slightly new as well. Rested, restored, ready to meet whatever comes. For now, just darkness.